Question 15. Prove the identity below for all permissible values of x. So it's sine squared x divided by secant x plus 1 equals cos x minus cos squared of x. I'm not a big fan of how they write these problems on your paper because it makes it look like you got to do both sides. In an identity, you just need to take one side and make it equal the other side. You should start with the more complicated side. So usually division with a binomial is more complicated than the subtraction. So I'm going to start with the left-hand side. So my left-hand side, I better write it out here before I forget, is sine of x over secant x plus 1. Now I got to do some magic. I don't have an identity for sine, so sine is going to stay sine. Secant, I got an identity for secant, it's 1 over cos. And I know that's a step in the right direction because my right-hand side does have a cos. Now I'm allowed to multiply by 1, so I'm going to get a common denominator of cos x over cos x. And if we had to identify non-permissible values here, remember you can't divide by 0, so you'd have to figure out cos of x cannot equal 0, and what's your restriction. But we don't have to figure that out. It doesn't ask us, so we won't. But we'll continue on. So this becomes sine of x still on the top, because I have a common denominator. The common denominator is cos of x on the bottom. And on the top is 1 plus, and then 1 times cos of x is just cos of x. So this is wonderful, I hope. I don't know if I'm getting any further, but I'm going to multiply by the reciprocal. So this is sine of x multiplied by, so flip it around, cos of x over 1 plus cos of x. And unfortunately, I think I hit a dead end. I really do. I'm kind of disappointed in myself. So this is the thing about identities. Sometimes they just don't work out. And, oh, I copied the question down wrong. That's probably the reason. This is sine squared. Yikes. So let me see if that can help me any. Sine squared. Sine squared. Well, I want to stop this for today. Whew. Or should I persevere? Well, I do know the right-hand side is all cosines, so I got an idea. Instead of saying sine squared, I could say 1 minus cos squared. All right, and that's great. But 1 minus cos squared is a difference of squares. So a difference of squares, right? Remember difference of squares, a squared minus b squared, right? Remember, a squared minus b squared equals a minus b times a plus b. So I could write this as 1 minus cos of x times 1 plus cos of x. And that's a step in the right direction. And I'm glad I persevered here. But I'm using up a lot of paper. 1 plus cos of x will cancel out 1 plus cos of x. And so what am I left with? I'm left with 1 minus cos of x times cos of x. And this is a multiplication. I could certainly expand this. So cos of x times 1 is cos of x. And cos of x times cos of x is cos squared x. So, did my perseverance pay off in this proof? Yeah, it did, right? Cos of x minus cos squared x. way up there. So I could simply end this by saying this equals right-hand side. And I don't have to do anything on the right-hand side because I've simplified and found the right-hand side equivalent. This was a tricky proof, but it is quite common that you write cos-squared x as a difference of squares. So it's nice that they asked this one so we can practice it. I would suggest you try this on your own, and maybe you can find a better, more efficient way. But we did everything that made mathematical sense, so I'm assuming we would get our 3 big marks.